Now, continuing our discussion, I have just now discussed this Newton's formula F is equal to minus eta A delta V by delta x in the context of this diagram. You remember, I just tell you this shaded portion, just look at this shaded portion. Shaded portion is the area enclosed by the two layers under consideration. It is the area enclosed by the two layers, this shaded portion. Okay, now I want to discuss the definition of this viscous coefficient of viscosity. Okay, I write here definition. I want to define definition of eta. Now I want to define eta. So for A is equal to 1 and delta V by delta x equal to 1, we get F is equal to eta. Again, dropping minus sign, negative sign, because negative sign shows it is the opposing force. So negative sign can be dropped. So what we can say here, how can we define the coefficient of viscosity? You can write, hence coefficient of viscosity of a liquid is defined as coefficient of viscosity of a liquid is defined as a tangential viscous force required to maintain a unit velocity gradient between the two layers, if the or provided the area enclosed by these layers is unity. The area enclosed by these layers is unity. Okay, we can define it like this, and obviously I hope you all can find out dimension of eta. It is ml minus 1 d minus 1. I just remind you, we have already discussed. Now as you have got the formula, so you can very easily find out the dimension of it. Because I have told you how to find out the dimension, how to get the dimension of a physical quantity. उसके formula को apply करके सबका dimensions put करके we can find out the dimension of that particular physical quantity. I hope that you can do. Fine. Okay, now this is this part here regarding Newton's formula and all. Now a very important law, that is the Stoke's law. Look, suppose this is, here is the viscous liquid and a solid of radius r. Okay, just see the situation. It's a vertical column in any, suppose, cylindrical vessel. There is a liquid, viscous liquid, in which a solid body is dropped. Generally in the laboratory, in the experiment, as a part of the experiment in the laboratory, glycerine is taken in a cylindrical vessel and the steel ball, right, or steel spheres, they are dropped. What will happen? If it is dropped, it will move inside this, right? Suppose it is moving inside this with a certain velocity. ये move कर रहा है नीचे की ओर. Then, according to Stoke's law, definitely a viscous force F will be there, which will opposing the motion. Viscous force is always opposing force. According to Stoke's law, viscous force, F depends upon following factors. Viscous force F depends upon following factors. क्या factors? Number 1, radius of the sphere. Number 2, velocity of the sphere. And number 3, coefficient of viscosity of liquid. According to Stoke's law, ये इन तीनों चीजों पर डिपेंड करेगा. It will be depend upon these factors. So you look at this very easily. You can see what are the important factors. Viscous force will be depending upon, F will be depending upon the radius of the sphere, velocity of the spherical body, and the coefficient of viscosity of liquid. Now, I want to establish a relation between these. Radius of the sphere R, it is V, and here is eta. I want to establish a relation among these quantities by the method of dimension. If I say by the method of dimension, that means F is depending upon these factors. Again, I just remind you how we have used this method of dimension. In that, what we shall do? We shall consider F is directly proportional to R to the power A, V to the power B, eta to the power C. This is the process. Or we can say F is equal to K is a constant of proportionality, R to the power A, V to the power B, eta to the power C. And I hope you can see mLT minus 2. This side is the force. K is always considered to be a dimensionless constant. So L to the power A, LT minus 1 to the power B, and ML minus 1 T minus 1 to the power C. Look at this. Or you can say here M to the power C, okay, L to the power A plus B minus C, and T to the power minus B minus C. Here it is, like this. Okay. Now you equate, I write here, equating powers of M, L and T from both sides. If you equate, what you will be getting? You will get C is equal to 1, definitely. C is equal to 1. Okay. Then you take minus B minus C is equal to minus 2. It's very simple. जैसा मैथमेटिकली करते हैं, पहले हमको C का मिल गया, then T का powers, equating the powers of T. Suppose minus B minus C is this. So what we shall get? B plus C is equal to 2, which implies B is equal to 1. Because C is 1, that's why. And now A plus B minus C, okay, L ka power, that is equal to 1, and you will just see A is also equal to 1. That means what we shall get? F is equal to K, okay, R, V, eta. You just put the value and you find out. I hope you can get it. No problem. A ka value, A, B, C, all values have come to be equal to 1 by the method of dimension. So we are getting this value, and you all know that it is the limitation of the dimensional method that value of constant of proportionality cannot be determined by this method. That's why here K is found to be 6 pi. So F is equal to 6 pi eta RV. Look, 6 pi eta RV. This is the formula. It is the Stokes formula. F is equal to 6 pi eta RV. 6 pi eta RV is the Stokes formula. Very simple. Okay. So it is Stokes formula. You can consider this. I hope this is about the Stokes formula, a very important formula in this field, and we have determined it with the method of dimensions. Alright, I hope all of you have understood this thing. So in the next lecture, I am continuing it.